Well, I'm Nate Boot. I go by Nate. Welcome to Tuesday, February 4th community meeting. Today's is at 3 p.m. Pacific time to try to accommodate for some other time zones to come and join us. I hope everyone is comfortable with the time. No one's staying up too late, or at least unreasonably late. But yeah, we should have a fairly uneventful meeting today. We've got a couple of announcements to make before we start. The CFP has closed for OpenSearch and all of the evaluations are done. So if you've received your notification about your talk being accepted, many congratulations to you. And if you have not, I do apologize, but better luck next year. We always look forward to those submissions, and I assure you, it's an agonizing process because there's so many good submissions that we want to include, and we just can't include them all. So please do submit them. And, we do have other conferences coming up. OpenSearchCon North America is still going to happen. There may even be an OpenSearchCon India, and there might even be others in the works. So don't give up just yet, and submit those CFPs for our other conferences if you're hoping to get those reevaluated. Okay. I usually start this out by reading a bunch of etiquette. I'll spare you my reading straight off of the slides this time. I think the only etiquette that we ask is that while we have a presenter, if you have a preference as to whether you want questions at any time or save them until after your presentation, let us know what your preference is, and we will do our best to accommodate. The default behavior for us is to just ask as soon as you feel like it.
Is great. You just ask. I'm here for you. It's a nice small group, so that works. And if you prefer to ask your question in chat, drop it in chat. And Nate, if you can if someone drops it in there and I don't notice, just mention it. So
Yeah, I
well,
think I will hand
yes.
it off to Eric here if no one has anything for the good of the order.
Awesome.
Take it away.
All right, you guys see my screen? Do I get a
Looks
thumbs up,
good.
Emerson? Thank
Just
you.
for posterity, we're seeing an entire screen,
Yep.
not just a single window.
Perfect. That's what I wanted. So yeah, I got a couple of slides, and then I'm actually going to show you some running code, and hopefully it all hangs together. And the demo gods are kind. Ask me questions as we go. This next slide feels a little redundant since I already know most of you, but not all of you, right? So I work for open source connections, and we focus on building empowering search teams, and we really dig a lot into what I consider the value side of search, not the cost side, which is how do we actually get our users what they're looking for and balance that with meeting business objectives. So if your business is based on search and you need help on those objectives, that's where we come in, and we do a lot of we share basically everything we learn. So that is us. So what I want to, and I'll share these slides afterwards. I'll get into you, Nate, and you can figure out the best way to disseminate them or put a link on the meetup. So okay. So search quality evaluation framework. What does that mean? Well, the challenge is, what is good search, right? We all know that if I ask a question, if I ask Eric Hatcher, what is the best football team playing right now? And then I turn around and I ask, Andre or someone else in Europe, what's the best football team playing right now? You might get wildly different answers, and yet they're both either good or bad answers, right? So coming up with what is good search is a challenge, and Of course, Eric, you had to, mess with my analogy here. So it's difficult. And we each struggle to put ourselves in the shoes of our users. So, what if we just ask our users what is good search? Let's use their click behavior. We're all gathering, right? In all of our search applications, we all have it thoroughly instrumented so we understand what our users are doing. We know what documents they're seeing, we know what they click on, we know what conversions are, we understand their behaviors. And their behaviors, their clicks at scale, right? Not in the small, but in the large, benefits from the law of large numbers. And it helps us understand which search results are good and which are bad. Now, that's nice, but we also we can't optimize search by looking at individual queries. We might try, we might even make some progress if we're looking at, say, the head, but definitely not the shoulder or the long tail. So we need to roll our metrics up. We also know that when we are looking at user behavior clicks at scale, there's a lot of messy data in there, right? So we need to aggregate our metrics. And you may be familiar with like NDCG and some of these other classic information retrieval metrics. They're all useful for looking at lots of search behaviors. So if we can visualize the individual results, the individual quality metrics for our searches into aggregates, then that opens the door for us to start experimenting, right? We are very big on experimentation at Open Source Connections. And we are really excited to be able to experiment with different algorithms, either algorithms modified by human beings, relevancy engineers, or modified by machine learning algorithms and other techniques at scale. But these algorithms, you can evaluate algorithm A against algorithm B by looking at what are called implicit judgments, judgments driven by the click behavior of our users. Is implicit judgments, that phrase, new to people? Everybody familiar with that or have a sense of what an implicit judgment is? It's an evaluation of a query and a document and how attractive that document is, that result is to users who type in that query based on what their click behavior is.
So not by explicitly asking them, hey, was this
Correct.
search? This is
Correct.
the
That would be
they've clicked
explicit judgments.
right.
We
So
ask
they've
subject
clicked on
matter experts, expert users, do a survey, ask for thumbs up, thumbs down, right? Those are a different type of metric and can be very useful in a more pure way, but doesn't pick up. One of the things that we know is we are all biased. Even those of us who claim we have no biases are biased to not having biased, right? And biases can be bad or good, right? But we want to understand those biases, right? Broadly speaking, someone who lives in the United States is going to answer American football teams for that question I posited. And broadly speaking, someone in Europe is going to refer to a soccer team, right? A football team. Now, we're using the law of large numbers, so people like Eric Hatcher with his Santos FC don't skew our assessment of what is the best football team playing right now if you're from the United States. So, okay. So Stavros and I and Aruna at OpenSearch Con back in San Francisco last year talked a little bit about the User Behavior Insights Initiative. That is not what we're talking about today. We're assuming user behavior insights is a way of capturing those clicks. But what I'm showing you today sort of starts with I know what your queries are, and I know what you've looked at, and I know what you've clicked on, right? However you get that, Adobe Analytics, Heat, whatever tooling you use to gather that data, that's what we're building on in this search quality evaluation framework. The model that we're using to evaluate the attractiveness of a document for a query is called clicks over expected clicks. Why are we using it? Because it's been around for a while. It's well understood. It's actually used behind Amazon's shopping team uses it. It has its own issues, not the most sophisticated, but it's pretty easy to implement. And the way it works is that we start out with understanding what is the overall click-through rate at every rank or position. So rank 1 is the first document, rank 2 is the second document, rank 3 is the third document. And I'll be showing some code that actually calculates this, but in our model here that we're looking at, right, what we're understanding is that 44% of all the clicks are at position 1, followed by, or click-throughs are at position 1, followed by position 2, position 3, position 4. And that makes sense, right? We generally click on the first thing that is presented to us, and that curve goes down. And so that gives us a sense of what is, what is the curve for our site, e-commerce, whatever. And then for every query and document, we start looking at what is their click-through rate individually. And what that allows us to do is build a scoring model, this clicks over expected clicks, that tells us how attractive it is. We know that if you're in the first position, you're going to get a lot of clicks. So document 1 in rank 1 that had 110 clicks, it's not actually the best document, right? Even though it gets lots of clicks, because it's in position 1. Everybody in position 1 gets lots of clicks. So 0.98. Whereas this one down here in rank 2, it only got 30 clicks. But we know that position 3 gets very few clicks, right? 12%. So it actually gets a very high. This document here is considered the most attractive document for this query. So if I wanted to score the best in my ideal world, I don't know, Emerson, you want to tell me the order of these documents? What should the order of that should be a 4 right there. What should the order of these documents be?
Maybe the third document should be the first.
Yep. And then this guy in second position, this guy document 1 in third position, and of course this bad one down here lives at the bottom, right? And if we did that, if we rolled out an algorithm that resorted them according to that, using our implicit judgments, we would be able to reason, right, that our new algorithm was better than our old one. The value of this is we can do that test without running an A/B test, without exposing real users to our crazy harebrained ideas, right? Because let's be honest, most experiments fail. We return worse results. And so, right, we want to be experimenting not on real users, but offline. And this is a great model. And then once we've got a good candidate algorithm, we do our A/B testing, our interleaving, however we want to do it. Okay. So moving right along, keep it on the clock. Right. So what we talked about back in San Francisco is, writing some code for OpenSearch where we were evaluating 10 million queries and 150 million events, right? That was going to be our corpus that we were going to run our implicit judgments on. And we wanted to build this in a way that didn't require like a massive Spark cluster or anything else, and something that was shareable among lots of different OpenSearch builders, right? Becomes a core part of OpenSearch. And so this is the pipeline that I'll actually be showing you, which is we start out with some events and some queries, and I'll bring up a little website. We'll generate a couple. We do some intermediate calculations. We need to know what the click-through rates are. We need to understand that based on the ranking that they are. We have a pluggable click model. We're using COEC. You can provide your own. And out of that, we get our implicit judgments. So I'm going to show you that. And this was captured in this RFC, right? That we opened back in August of last year. Was this RFC around this implicit judgments. Now, coming out of that, and I'll be showing you some nice dashboards, some pretty dashboards in OpenSearch UI, OpenSearch dashboards, OpenSearch UI, right? That delve more into it. But the idea is that we need to look at these queries and we need to understand at an aggregate level, but we also want to dig more in detail. So this is what we're going to be showing. Okay. Questions for me so far? Aruna, Stavros, you guys are super familiar with this topic. Anything else you want to say at the high level before I jump into the demo?
And this kind of thing is currently in use by a lot of people, yeah?
Yes. The problem is everybody builds it themselves over and over. And it becomes a big engineering effort. And it also becomes a long-term maintenance pain in the butt. You got to build the Spark cluster. You got to run your calculations. You need your data scientists to figure out what COEC is. And honestly, this should be table stakes for any search team, right? Any search team that has clicks should be using this. We focus, this is what lets us focus more on the value side of search and not just on the cost. How many shards, how many clusters, right? And so you can say, hey, look, we ran these experiments and we are meeting these business objectives. How do we do it? Using things like implicit judgments. So yeah. And this is us, yeah, Stavros.
Yeah, I was just going to say that, yes, a lot of people try to do this. Some of them even do it correctly, although we've seen a lot of flawed implementations. And often what seems to happen, even at very large customers, which surprises me, is that some enthusiast does something or some consultant does something, and then no one actually knows what it is. And a year later or 2 years later, no one really knows what the numbers mean and how to correct it. And then something gets changed upstream of it, like the data collection method, and suddenly it doesn't work anymore. It's very disheartening to see this kind of thing. Same thing happens with data collection, which is again why we worked on UBI, that a lot of people try to collect data. Some of them do it right, mostly not. And then it tends to get abandoned as a project because management tends to go for, okay, fine, you've done all this great stuff, so we don't need to do that anymore. Now let's improve our numbers for raisins. Raisins aren't selling well. How are you going to sell more raisins?
Yeah. And so by bringing this into the OpenSearch ecosystem, we're leveraging the power of OpenSearch, those dashboards. We're leveraging the data structures, and we're giving these features to our users. A lot of this kind of stuff does exist in various commercial tools out there, right? But as far as I know, what we're doing here as part of OpenSearch is not available in any other search engine, open source search engine. So, all right, so demo time. So I have 2 links here. So the first one here well, actually, I'll bring up the first one. So this is the code base. And one of the things that we're working on with some other folks in the OpenSearch community is how to properly deploy the functionality into the OpenSearch project, right? We have some dashboards, we have some Java code, we have some scripts. How do we bring it in? So it's currently under this repo until we migrate it in. You're going to see a lot of new documentation and releases around this between now and the 3.0 release around that. So I suspect that this will be fully in ideally OpenSearch, ideally managed OpenSearch in the 3.0 timeframe. Everything I'm showing you, though, works with any version of OpenSearch, any modern version in the 2x line. There's nothing that requires something more specific, but we would like it to be part of the product, out of the box, the dashboards, etc., ship with it. Okay. What we have here, Chorus is a reference implementation of search. This is for OpenSearch, right? And it's not meant for you to download it and go build your e-commerce site on top of it. It's meant for learning and understanding. And one of the things that we got a lot in here are various sort of structured learnings that we call katas that you can go through to learn how do I do hybrid search in OpenSearch? That's a kata. How do I protect my sensitive information like the margin on my products while collecting that data using UBI? That's a kata, right? So this is something that we use. You clone it, run the quick start, and you could follow along with me right now. Okay. So I'll bring those two links back up. And then I'm going to go ahead and jump in. Now, there we go. I am starting. So here I am. I'm on Chorus. It's a retail website. The data you're looking at is actually the ESCI data set from Amazon. Thank you. And Valentine's Day is coming up. So I want to get my wife something gold. I don't have a lot. All right. And so I'm looking at these results and, I can't tell. Oh, that's definitely gold, right? So I'm going to go ahead and add that to my shopping cart. That's a conversion in our parlance. We got a bunch of other random stuff in here that I'm not sure happens to be gold color, but these are not jewelry. This isn't anything I want. I mean, that's white gold, maybe, right? I mean, it's definitely gold. And then, this is cute. I'm going to add some more. Okay. This is the standard shopping experience. And under the covers, I am tracking, and I'll show you the data. I'm tracking the search that I just did and what the user and what the shopper actually did, what they looked at and what they bought. Let's do wireless earbuds. All right. Again, okay. Ooh, skull candy. So now I'm shopping for myself for Valentine's Day. Oh, that's kind of cool. I'm going to get that, right? And now we see we have a lot of accessories, right? Chorus's e-commerce site, not good with the accessories problem, right? Foldable Bluetooth. That looks like a Bluetooth headphone. So I'll add a couple of those to my shopping cart. Here are a couple of more. Wireless in-ear, maybe, right? I'm not totally sure. That is a wired earbud. I'll go ahead and grab it though, because it is. And then, we got a couple more right there. Okay. What I'm doing right now behind the covers, gathering all of this data. Okay. And let me show you. Let me grab my. So I am going to jump into my dev tools. So what I want to show you here is that we are gathering data. Notice that we have this UBI queries index. We have a UBI events index. These are indexes that are dedicated to capturing the data that we're looking for. Okay. For those of you who haven't heard about UBI, happy to talk about it more. It's basically a standard for this type of event. So however you gather this data, as long as you drop it into OpenSearch in these formats, then you can use it. So here you can see I did a search for this user.
Eric.
Yeah, please.
So to accomplish this, Chorus didn't come out of the box with this built to send these into OpenSearch. You had to modify Chorus and instrument it to send these events to OpenSearch.
Correct. And maybe a slight segue, but I'll go ahead and do it.
Oh, don't let me stop you.
No, we're all chickens here. Notice this ubi.js. This here, this library is sourced from the OpenSearch project, the User Behavior Insights, and it's a very simple little piece of JavaScript for gathering that data, right? And I think next month at the community meetup, I'll actually be doing a deeper dive into what UBI looks like today, how it's integrated with OpenSearch ingestion. So if you're on managed services, you use OpenSearch ingestion, you use a little piece of JavaScript, feed the data OpenSearch ingestion, and it pumps it into the right location to do everything that I'm showing. It gathers all this data. So yes. So here you can see we have a lot of information. The important thing here is we're starting to understand what documents were returned, right? So you can see here's a number of different queries, what documents were being returned, right? I've got some partial, like as I'm typing my queries in here, but I'm gathering the data and understanding what was being returned. Maybe more interesting, however, is the events, right? We already are all used to gathering, looking at logs that say, this is what I got this query, I sent these docs back, right? That's a well understood server side problem. What we're really interested here is understanding what is happening on the client side. And so here you can see a whole bunch of events. Add to cart. So here's an example where this document was added to a cart in relationship to this query. And you can see it down here, right? For wireless earbuds, someone added it to cart. Here you can see that here are some other, a click, right? Someone was, that sort of, someone like did a click through. They were interested in it, right? They're expressing that they're interested. We're gathering all of these events, and this is standard user analytics, right? Like in the user analytics world, that's what you do. You gather lots of information. And as you can see, just in the little bit of clicking around I did, we gathered 195 events, right? We're leveraging the power of OpenSearch to scale and bring in data that I can manipulate at near real time to do some of this. Okay. So does that make sense, Nate? That right? We got our queries, we got our events. We're now ready to start and imagine this at scale, right? 150 million events, 10 million queries, right? That's what we're building for, right? We want to know, right? We want to know in the last 3 months, what do people like? What do people not like, right? And we want to do this on a regular basis because it doesn't really matter to us what people thought a year ago, 3 months. We care about some sliding window, okay? Well, one of the things that we need is to understand, we need to sample all the queries, right? We can't work and experiment with 100 million queries, right? How long does it take you to run 100 million queries in your OpenSearch environment? Some non-negligible wall time, right? And so what we have to do is sample, right? We want to sample our queries. And there is a very popular algorithm. It's a proportional probability sampling algorithm that says we need some head, we need some tail, we need some shoulder, and we want to get them in proportional. That algorithm is actually built right in to what we're doing. So let me switch over to some command line. All right. Someone give me a thumbs up. You can see my terminal and read this. Excellent. You want to know how I know when it's time to go to bed and it's too late to be coding? When that GTI runs across the screen. That's what tells me it's time to go to bed. All right.
Alias.
So in Chorus, we have a copy of our data in a search evaluation framework. And we have a couple of little scripts here that just run the Java code, right? And they're what I'm going to use. So in order to build my implicit judgments, I need to get some queries, and I want to sample them from my live production traffic, right? All that, all that data. So I have a very simple little config file that just says, I want 500 queries. Now, if you notice, I only had 2 queries, gold and wireless earbuds, and the autocomplete, or as I was typing them. So we're only going to have like a couple of queries. But I'm saying, this I could use to sample 500 queries or 5,000 queries or whatever I want, and it does it in a statistically reliable way. So let me go ahead and /create query set, and what this is going to do is ignore my old Docker containers. There we go. We're firing up some job. All right. This happened earlier. Oh boy. We'll see how my demo god works for me. All right. Otherwise, I got to work around. So that's what I get for.
You're doing fine. Carry on.
Excellent. All right, let's go see if we actually got data. Otherwise, I have my crib sheet right here to work right around. So, yep. All right. The alternative, which becomes very important when that didn't work, is I can also just define what are the queries I'm interested in, right? I know I don't care about all the other queries. I just care about wireless earbuds and gold. So I'm going to go ahead and I can give a sense of where they are, head, tail, by the number. I'm giving them both that they're the same value. So I'm going to go ahead and run that. Okay. And now I have a evaluation set, and there's my specific queries. I gave it an ID. It's a number. I can have as many as I want. So I might have like baseline metrics. I might have, semantic search related queries, whatever the different domains I want. So, all right. So the next step, remember I mentioned COEC, clicks over expected clicks. I need to go ahead and calculate that. So this create click model script is going to go ahead and for each of my query sets, it's going to go recalculate them with the raw data that I've collected, right? So this is how every night, every week, every month, I can recalculate based on the most recent user traffic. All right. And as you can see, lots of output coming out. And what we're looking at is we're trying to understand for every query and every document, how frequently did it show up compared to overall how many. So we're just cranking right through it. Okay. And this populates 2 indexes. We have our click-through rate. And this goes back to that table that I showed you guys. So for example, this product here for the query gold, it was shown 4 times and it got clicked on once. So does that make sense that the click-through rate was 0.25, right? This one here was shown 3 times, got no clicks, click-through rate of 0. This was, whatever this was not attractive to our users, right? And so we can go and scroll down through here and, there's a bunch of data in here. Now, we also know that we need to understand how frequently are people clicking at position 0, 1, 2, 3, 4, 5, 6. And so if you guys noticed, for both of my searches, wireless earbuds and gold, the very first item, was actually totally not a good item, right? And you can see that reflected that the click-through rate in position 1 is 0. That's kind of weird, right? And with more data, you would expect it to be a high number. But you can see that position 2 got 25% of the clicks. And position 3 got 12%, 4 got none, 5, and our rate kind of went straight down because we don't have a lot of clicks. But this gives us a sense of at each point, on average, what percentage of the clicks are. That is important because what we're trying to understand is which documents are judged as more attractive for a query document than you might expect at the average at that position, or which documents are underperforming as well. And so, for example, this product here for wireless earbuds, it gets a high judgment. Our judgments are on a 0 to infinite scale in the implicit judgments world. In explicit judgments, they're typically on a binary or a 0, 1, 2, 3 or some other scale. But in the implicit judgments, they can be whatever they are. Here's another document that for the query goal, 0.88, right? So it's considered pretty good. And then now we get a bunch of documents down here that aren't very attractive. This lets us understand for every query and document pair, what do our users, based on their click impressions and clicking, think of this product? And that's that clicks over expected clicks model. Okay, that's great, right? But those are, we have 49 of these, 40 of these judgments, right? What does it mean? How do we convert this into numbers that we can use? Well, we also calculated, okay, we're going to go ahead and we're going to use this data to measure an algorithm using standard NDCG, DCG, and average precision. So, all right, I need to clear ls. So I have a file called runQuerySet.json. And what this guy is going to do, query set, I'm going to grab my query set. I actually know what it is. It was 1 because I put it in with the name 1. So I'm going to test these two. I'm going to measure these using implicit judgments to get a sense for an algorithm how well they're doing. So query set ID is 1. And what judgments am I going to use? My judgment set, right? So I may have multiple judgment sets and, I get to pick which ones I want. So we'll go ahead. Now we are using an e-commerce index. We are not testing our hybrid search. We're just testing regular old TF-IDF BM25. That's all the same. But we don't want to use this default query. We actually have the query that you were seeing in the chorus experience. So let's see if I can go DD. And so as you can see, I'm putting in the specific query. So this could be any query. I am running an experiment, right? Research number 1 is my experiment. And I believe that this, I want to know how well this one performs. Okay. And so now I've set my configuration up and run query set. And JSON. All right, what did I do wrong? Oh, there it is. All right, as you can see, I quickly ran those 2 queries that I had picked in my query set, gold and wireless earbuds. Let's go ahead and see what we calculated. So I'll go ahead and search quality evaluation metrics is the collection that stores all this data. Hey, all right. So we called our configuration research 1, right? And search configuration is something we're interested in exploring more. There's the query set we're using. So for wireless earbuds, DCG at 10, discounted cumulative gain, was 0.95. That's what we calculated. And all of our data was in there. Our NDCG at 10, and for those of you who aren't familiar with NDCG, it lets you compare different queries to each other, regardless of the number of results returned, because it's a 0 to 1. And so we got a 0.63, right? Not bad, not terrible. Could be better. It could be a 1. That would be perfect. I returned the wireless earbuds that I wanted, but that's what I got back. For gold, NDCG at 10, I got 0.5, right? So not quite as good as my wireless earbuds. I potentially could decide to look at the gold. I've got some other metrics in here, average precision, etc. Okay, we got metrics, but we got a lot of little metrics. What do we do with that? So what I am going to pull up is OpenSearch's dashboard. So these are dashboards that we just loaded directly into OpenSearch, right? They are built, they ship, you just download and insert them into your OpenSearch. And what I'm going to pull up first is the search configuration comparison. Now, the dashboards I'm going to show you, as you noticed, with 2 queries and a couple of clicks, the data is not really meaningful, right? I need 150 million events, 10 million queries. Larger data sets become much more meaningful. And this was generated using some synthetic data to simulate some user traffic, okay? So that's kind of why it looks a little different and different queries. So in this dashboard, how much of an eye chart is this for everybody? Font looks a little small to me.
It's a little small. In your Zoom window, you can actually use your mouse wheel to zoom in on the screen share if that helps anyone.
Let me try that. Does that make it bigger without messing the formatting up?
It does.
A little bit. Okay, great. So what I want to show you here is that, these dashboards ship, and you use these dashboards to evaluate your search. Here, we mocked up some data last year, and we had 4 algorithms. Baseline, Challenger 1, which appears to be doing slightly better than baseline, according to our NDCG metric. And then you can see we had 2 experiments, Research 2 that did better than Research 1, but neither of them exceeded the baseline. So are we going to A/B test either Research 1 or Research 2 with real users? Nope. Because we already know, looking at our data, that they're not better than what we have. We're going to A/B test our Challenger versus our baseline so that in production, we see if our Challenger does convert over our baseline. We see that it is slightly better than our baseline. So we have an intuition it will do better. That's where production comes. I can look at those metrics aggregated, right? So the average value of NDCG, and NDCG is meant for comparison, right? As 0 to 1, you can see that Challenger 1 scores a little bit higher than baseline and definitely more over Research 2 and 1. And, again, here's some other information. This score density is sort of a fun one that I really like. That have not used much in other systems, but the power of OpenSearch dashboards made this. This gets us a sense of how many of our queries are scoring at different points, right? And as you might imagine, for baseline, they're all kind of around the number. Challenger 1, actually has, notice we kind of come out a little below 0.8. Challenger 1 has maybe some worse results. Notice the tail is a little longer compared to the baseline, but it also has some slightly better results. It gets closer to that 0.9, right? And so that's what's making it, it's still not quite above. You can see research 1 and research 2. One of the reasons these types of plots can be interesting, you might look at an algorithm and it does really well at the head, or at the, some queries score really well, others score really badly. And on average, it gives you a number. You may decide that you'd rather have a less effective algorithm for the best performing queries in order to move more of the low performing queries up the curve, right? So, that old joke that if your head is in the oven and your feet are in the refrigerator, then on the average, you're perfectly fine, right? Here's another kind of fun visualization. Often in search, we're trying to understand, like, why do we, what are our underperforming queries? What this lets us do is look at a query, and, we're in an e-commerce. Cole Haan Grand Cross Court. Well, Cole Haans are a type of shoe, and I expect that Grand Cross Court is a model or a type. We can use this data to start understanding, why are these queries performing so badly, right? And if we think that, hey, this is a product we should have, maybe it's out of stock. Maybe we mislabeled it, right? But all of a sudden, we can start focusing on the, potentially underperforming queries that we think should be performing well, and, ignore sort of the ones in the middle. And this lets us start to prioritize our efforts. Want to do a lot more around this. And then the last thing I want to show you before we wrap up is the single search configuration. And this is where we're actually starting to dig into not comparing different experiments, different algorithms to each other, but digging into one, right? So here we're just looking at our baseline. What is our baseline doing? According to NDCG, we can come in here and start looking at different queries and start understanding how they are doing, and maybe get some intuitions out of what we're doing well with and what we're not. We can track over time our evaluations. Not much happening, right? Got slightly worse. Who knows? Data changed. Users just decided their interest changed. But this starts giving us a sense of different queries, what things are doing, that same score density, the same visualization, right? Of some of these queries are doing really badly and some are doing much better, and getting a sense of that. So that's kind of the pitch. That's the demo. Yeah, questions? What can I answer for you? So
It's a bit to take on at once
it's a lot.
for someone who's not used to, like, search algorithm comparison. Do you have any literature that someone who's not quite as versed as you and your team
Yeah.
through? And then
So
one or two follow-up questions after that.
yeah, so I think first thing, Doug Turnbull's Relevant Search is a great book, right? And definitely the Bible. It's kind of getting longer in the tooth now, but it's definitely the Bible. This is going to be a shameless plug, but if you're interested in this domain, Haystack, right? Aruna, Stavros were there last year. We'd love to see more people. That's coming up. It's an entire conference dedicated, 2 days, workshops. We're going to have lots of OpenSearch topics. I'm super excited. I think we're going to have 2 OpenSearch workshops, one of which at least will be covering what you saw today in more of a let's do it together workshop format. But that will be coming up as well. And then we are feverishly working on documentation and tutorials and how-tos for the OpenSearch project's reference documentation website that walk you through, all right, I want to do this.
So I'm curious about something here. We are at 3 minutes to the hour. If anyone needs to drop, that's fine. I'm curious about one or two things here. So I'm trying to envision differences between use cases. And so I can imagine like a place like Netflix, they might want to incorporate explicit with implicit judgments in the
Mhm.
case where like someone does a search for
Yeah.
some free-form text, but then they want to rank things that people have rated explicitly higher. So there might be some kind of
Yeah.
use for
Absolutely. So I think you're asking two different questions, really. You're asking two questions in one. One is, what are useful ways to rank things? Like on Netflix, you might want to take into account various criteria other than relevance. And the other is, how do you tune that? The how do you tune it has partly to do with this kind of data that Eric's been presenting, partly also to do with things like, what are you pushing? Maybe you want to push the latest releases. Maybe you also know that the latest releases, no one knows about them, so you have to put them up near the top of the results so that people will discover them. There are all sorts of things like that, which aren't really connected directly to the relevance metrics that Eric's talking about, because they're business goals. The business goals say, oh, we just invested $10 million in this TV show. We want to make sure that people are aware of it. So even if you searched for police and it turns out it's a spy thriller, maybe you still want to show it. So that's really not a relevance issue. And Eric's colleague Renee has had a really nice talk about this. Because relevance is one thing. That's sort of the first step. You say if you look for potato chips and you return pork chops, you're probably not doing a great job. But if you look for potato chips and it returns, let's say, some sort of potato puffs or something, maybe that's marketing. Maybe that's merchandising. Maybe you want to do that. Maybe you earn a larger margin on those than you do on regular potato chips. So, uh, yeah, all of that stuff you want to take into account the popularity and this and that. Netflix, by the way, is famous for how many years ago? Was it 10 years ago, the Netflix challenge? Uh,
Yep.
they did a machine learning challenge. It says, can you put together a machine learning system that predicts better than our existing system what people are going to rent? What movies they're going to rent. And there's a very large prize. What was it, $1 million prize or something?
Yeah. It
Uh,
was substantial.
and in fact, the winning team did better than anyone else by a noticeable margin. And you know what? In the end, they didn't deploy the algorithm because I assume because it didn't meet their business needs. It probably was very good at predicting what people were going to click on, but that wasn't their only goal.
likely for
Um,
reasons that you mentioned just a second ago. Like there were other secondary and tertiary things they wanted to include in those results on purpose.
Exactly.
Maybe less exciting, more prosaic, but one of the things I'm excited about this is it lets me monitor my search quality over time. And we've all been there where like a data pipeline fell over and nobody noticed until someone important called and said, hey, I looked for this document and it's missing, right? This type of monitoring picks up those types of things, right? If all of a sudden our baseline performance goes down because we're missing data or we didn't properly attribute, you're going to get notice that, right? Maybe you find out that, maybe it drops because all of a sudden there's a new type of product or a new type of query that we need, right? You start noticing that kind of thing. We were working with a image search company, and they saw COVID before anyone else because all of a sudden people started looking for stock photos or vector graphics that had the word COVID in them. And they're like, well, that's weird. And if they literally sourced, hundreds of these vector graphics really quick to fill the need, they all of a sudden were able to see that this query, COVID health image, that should have done well, wasn't. And they realized it was because it was a brand new concept and they didn't have any content. None of it had been tagged, right? There was no COVID health poster that would match on wash your hands, please, or whatever other things that they had. That they had for flu and plenty of other use cases, right? And so this gives, a monitoring aspect to it. And then when people need to make changes to their algorithm, you need a safe place to do it without real users. And a lot of organizations it costs too much money to get expert users to label things. I love explicit judgments. Renee Kriegler loves implicit judgments, and we fought a lot about it over the years on the right use of them. What I will say is, if you have the click data, even though it's all biased and everything else, it also reflects what your users want today. And this is a lot easier to get than 5 or 10 expensive paralegals, doctors, whoever to sit and rate 100 queries 10 deep.
Yeah, but if you do have experts and it's an expert field, you may want that rather than what the people click on.
And that's one of the caveats, right? This is why this is one lens for looking at this, and we can't just blindly take it. And if we did blindly take it, Netflix would have rolled out that algorithm, right? But yeah, so.
Oh, and by the way, so I mean, those are two cases. Another interesting case is where you don't really know what's better or worse in an abstract sense. You don't have a list of good results. You don't have click data, but you know that your algorithm changed since last time. And you'd like to say, what changed since the last time I ran this algorithm on let's say 500 representative queries, like Eric was talking about. And so one of the things that we're very excited about, we're actually we have a paper about it at OpenSearch Con, is on the power of eyeballing. You say, what tools can we give you so you can say between these two versions? It's a little bit like a regression testing, except that search results aren't well defined. You don't know what the good ones are. And so if something has changed, you want to eyeball it. And it turns out my personal experience is that you learn a lot by eyeballing search results. You learn crazy stuff like, oh, my new algorithm is really good at finding, it knows that sofas and couches and settees are the same thing, but it doesn't actually know what 8 means in 8-foot sofa. And the previous algorithm, for whatever reason, did. So you say, oh, wow, whenever there are numbers in the query, the new algorithm isn't doing very well. Not something you can find with these statistics. NDCG is wonderful. You want to report on NDCG, but you also want to look at the results and say, oh, I get it. I see why the results are better in one way here and better in another way there, even if the NDCG may not have changed at all.
Eventually, yeah, we're looking forward to, here's a query, double click on it, some other interesting visualization. These were the documents that were returned, and the impression count, right? And understanding which users actually, and tracking it by, users, saw these. So
it makes me wonder, like in terms of the actual behavioral insights that you can generate, that in the future that may not be tied to just click-throughs and search terms, but like engagement times on a description, or like, in some dystopian future, uh, where your eyeballs are looking on the page and stuff like that. Are there any like really
Oh, that's been out
uh,
for a long time, actually.
well, I'm sure it has, yeah, with like, certain streaming places and commercials and whatnot. But like, what do you see in the future of behavioral insights? Like, do you think those are going to morph and change into things that are more exotic like that? Or do you think as things are now, click-throughs and engagement is uh, the most useful?
I think so clicks over expected clicks that we're using right now is a fairly naive model, right? It's pretty simplistic. It doesn't do anything interesting like, what is the business value of, what's the margin you make on that product, right? And it's a good first cut. There's a lot of other signals that if we can really model, and there's books and things around it, but we're getting the machine learning, we're gathering the data to build richer models for what are understanding our users. And then we could start thinking about things like, well, what is the user trying to do? What is the persona of the user, right? If I am using search as navigation, if I'm looking for one item, then really it doesn't matter, in my metric, as long as I get that first item right, that's what I care about. That might be a use case where minimizing the number of searches, minimizing the engagement is a good thing, Whereas if you're like, help browse around and explore and power my cross-disciplinary literature review tool, well, for that person, we'd want to show lots of maybe related, maybe not serendipity, lots of clicks, lots of engagement. That is a good thing, right? And this is one of the things is like all the models that I'm showing you right now, don't really think about what is the user's journey overall, right? Or, if I'm on your e-commerce site and I type, that query gold, it's a pretty broad query, right? It's very hard. Maybe the clicks would tell me I want gold means gold jewelry, but it's pretty broad. If maybe what I should have been showing is how to buy jewelry or what a diamond is, right? For those types of things, more educational.
Yeah,
we
how do
don't,
I pan for my own gold?
yeah, we don't capture a lot of that in our models, and that's the direction we need to be going in. But we need to like do that as part of the search engine. We need to maybe rethink a little bit of what a search engine is, right? To, for a while, people talked about answer engines. I think that was mostly marketing term, right? And kind of fell on itself. But, maybe search engines should know a lot more about who we are, what our goals are, what's important to us. And I think that would be, a lot of interesting talks, etc., on that topic could be had.
Interesting.
How to do it in a responsible manner, etc.
Excellent. Well, I want to thank you, Eric. That was pretty engaging. I like that very much. Thanks for coming out and sharing that with the crowd.
It was a pleasure. It was a pleasure. So any follow-up questions anyone want a demo, just hit me up. I'm on OpenSearch Slack. So
Wonderful. Okay, well, we are 9 minutes past. Definitely worth the extra couple of minutes. I will bid everyone farewell, and hopefully next community meeting will be first Tuesday of next month at 8 in the morning Pacific time.